Hi guys, you're welcome back again. We're going to solve for the value of x from this exponential equation. And the given equation is what? 9 to power x squared divided by 3 to power x is equal to 27. To solve for the value of x, the first thing we need to do is to try to make the base to be the same. So this 9 in index form to the base of 3 is the same as 3 to the power of 2. Because 3 multiplied by 3 is going to give us 9. Then all raised to the power of x squared. So everything all over 3 to the power of x, which is equal to 27 can also be written as what? 3 to the power of 3. Because 3 multiplied by 3 in 3 places is going to give us back 27. Now the next thing we're going to do, using power property of exponent, we can multiply the two power together. So we're going to have 3, 2 multiplied by x squared is going to give us 2x squared. Then everything all over 3 to power x, which is equal to 3 to the power of 3. Now recall the division property of exponent. Since the bases are the same, we can write one of the base, which is 3, then we subtract the power. So the first power is what? 2x squared minus the second power, which is x. So everything now be equal to 3 to the power of 3. Now what do you notice in this equation? The bases are the same, 3, 3. Recall, when the bases are the same, we can cancel out the bases, then we equate the exponent. So we can cancel out these 3 because they are the same. So the first exponent is what? 2x squared minus x, which is equal to 3. Now as you can see this equation, this is quadratic equation because the highest power of x here is 2. Before we continue, let's write this equation in quadratic standard form. So starting from the one that has the highest power, which is what? 2x squared minus x. When we take this 3 back to left hand side, become minus 3, which is equal to 0. Because positive here, when it's crossed, become negative 3. Now the next thing we're going to do, we have many methods of solving quadratic equation, but the fastest one we're going to use is to look at the leading coefficient is 2. We are going to multiply this leading coefficient by this constant. 2 multiplied by 3 is going to give us, 2 multiplied by negative 3 is going to give us negative 6. Now we are going to look for 2 factors of negative 6. When we multiply to get negative 6, and when we add together to get this leading coefficient, minus 1. There is invisible 1 here, minus 1. Now 3 and 2 are factors of 6. So because of this negative, let's add negative here. Negative 3 multiply negative 2 is going to give us negative 6. Negative 3 plus 2 is going to give us negative 1. So this is the two number we are going to use. And in solving quadratic equation using this method, what we are going to use is to use two brackets to multiply itself. Open two brackets, equate it to 0. So the variable we are looking for is x. Write x here also. Now we're going to put these two numbers. The first number is negative 3. The second number is positive 2. But remember, because of this leading coefficient, that is 2. If the leading coefficient is 1, we don't need to do anything. But because the leading coefficient is not 1, it's 2, we're going to divide the number by the leading coefficient, which is 2. Then also we divide this by 2. Now the next thing we're going to recall, when two terms is multiply itself and is equal to 0, so you said that one of them is 0. Before the right hand side can be 0, one of these brackets must be 0. But we don't know which one is 0. So we are going to equate the first one to be 0 or the second one to be 0. So we have x minus 3 over 2 equal to 0, or x plus 2 divided by 2 is 1 equal to 0. So this is the second bracket equal to 0, and this is the first bracket equal to 0. So x now be equal to, when we take this negative 3 over 2 to the right hand side, it becomes positive 3 over 2. Or x now be equal to, when we take positive 1 here, it becomes negative 1. So therefore, 3 over 2 or negative 1 is the value of x that satisfies this exponential equation. Thank you for watching, and please follow and subscribe for more videos like this. Thanks.